Hey everybody, welcome to the second assignment for chemistry this week. This will be your last assignment this week, and it looks really long, but it's not because I'm going to help you through the notes. And for those lucky people who are actually watching my video, you're going to have to do less than all the people who don't watch my video. So pat yourself on the back because you're doing the right thing. Let's get started. It's going to take a while. All right, so the assignment this week, or this second assignment, only 2 assignments a week, Friday's tutoring, okay? It looks like this, okay? Except I'm going to have to post this video on it, so it's going to have an extra thing on here with my face, sorry. But it's going to look like this. All right, so the first thing you do is, well, not that. Don't do that. That's not the right thing. All right, so I'm going to go back. All right, there we go. You are going to open, it says to watch the video on what you're doing right now, and it says to take notes. So we are going to open, you are going to open this tab right here. All right, so this is the document for the PhET lab, and we're going to fill this in together. So we're going to open this and we're going to open this PhET lab, okay? I have links for both of you. All right, so let's get started. All right, so the document says, says to turn on the grid, turn on the values, and place a positive or negative. All right, let's get that done. All right, so we're turning on the values, we're turning on the grid. Now, if we leave the electric charge there, it doesn't say to do that, but I want you to look at that real quick because this is going to help you with the lab you're going to do next week. All right, because it's going to show you the field, how the electric field actually kind of visualizing the electric field. All right, okay, so see all these arrows? That's the direction of force. All right, and if I put another one out here, it changes the direction of force. So what's happening here? Are they attracting? Are they repulsing? Well, look, they're different charges, plus and negative, right? They're opposite charges. Opposite charges attract. That's right. So we see the arrows going towards the negative. Okay, so this is what it looks like if you draw the field vectors. It's not really the point of today's lesson. You'll use that more next week, but I just wanted to put that out there, right? And so we're just going to turn off the electric field and we're going to pull this back down here because it says to do only one chart. So we're only going to do one chart. Now, we're going to start with the tape measure. We're going to put the tape measure right here. See that right there? That's where it starts measuring, okay, and in measuring right here. So we're at 20 centimeters. All right, so we're going to put the sensor. The sensor is going to tell us what the force is, and we are going to move these sensors so that this 20 centimeters is kind of at the heart of the sensor. I want it to be more than, it's really hard to get, it's a big jump from 219 to 246, right? Give me a break here. There's got to be something in between 219 and 246. Good Lord. All right, 219. So be it. Fine. All right, so then we put this down. Hello, there we go. So 219. And then our voltage is volts per meter. Just go with it. It's just a unit. All right, so we're going to say that's our 1/4. So this is our standard that we're going to measure everything off with. So now what we're going to do is we're going to change the radius. All right, so all of this is Coulomb's law. And it is, of course, an equation, which you are going to use at the end of this lesson, okay? But there's a discovery passage I want you to read, and there's a little video. It's going to help you through Coulomb's law. Okay, don't panic. All right, we're not using it yet. But if we were using Coulomb's law, it says force equals, this is just a constant. It's just a number. All right. And this is the Q, which is the first charge. And then this is the force between charges. So these Q's are two different charges. And then radius squared. All right. So what we're doing is we're looking at the force. That's what our sensor is measuring. And we are changing this. So we're changing this radius. So those of you who are mathies will know what's going to happen when we change this radius. But for the rest of us, let's just go ahead and do it. All right. Okay. All right. So now it says we're going to change the radius. So we're going to change it to 40 now. So let's do that. We're going to pull this out to 40, and we're going to try to get it as close as we can. It's a little off. It's a little persnickety. We're going to do the best we can. All right. And so then we got to move the sensor over here. All right. It says 58. I'm hoping that's giving me what I need. Let me look at it too. And that gives me, it's not great, but it's the best we can do. All right, so this is what this is going to look like now. It's not perfect. It's not going to give us perfectly what we need, but it's going to be close enough. All right, so we are seeing how the force changes. Okay, we know what the actual votes are going to be because that's what our sensor gave us, but we're seeing how this force changes. Okay, so this first radius, 20 centimeters, right, gave us a force of 1. So we're just seeing how that changes. All right, so we got 219, and we're dividing by the force that it gave us. And what was that? That I finally decided it was 59. Really? Wow, 59. Let's get that a little better. Okay. All right, let's go with 54. Whoops, you can't see what I'm doing. 54.9. 54.9. All right, could you thank you so much. 54.9. There we go. Volts, meters. All right, so how I'm figuring out this charge is I'm taking the original charge and I'm just, it's basically a ratio, right? So 219 divided by 54.9. And so we're just seeing how much of what we have. Yikes, not 2. All right, we got 3.98. So that basically is 1/4 of the force. So this is 1/4 of that. That should make sense. Okay, look, back here in our equation, right? This is Coulomb's law. If I can spell it right. Dude's name. Okay, this is squared. So since R is what we're doing, this is 2R. So 2 times 2 is 4, and it's in the fraction here. So this is, whoops, you can see that. I'm sorry. This is squared. So it's in the fraction. So it's squared. So if we do 2, it's going to be 1/4 of what the force is. Making sense? All right, let's do the next one. And this is going to take forever, ever. All right, so now we're doing it to 60. And can we, all right, 60. And move our sensor. Oh, and look at our red arrow. It's getting smaller. It's getting smaller because the force is what? Decreasing. That's right. All right, so we got 25.3. What do you do with that? That's right, you divide it into 2. Look, 219. Let's get that score. No, that is not right. Oh, ladybug. Yeah, there we go. All right, we get 25.3. We divide that into 219. Yikes. All right, we get 8. We get 8.6. All right, so it's not exact, okay? Just gonna round it. So that gives us 1/9 F. So you Matthews have already got this figured out and probably speeding ahead, which is fine. I don't care. These are your notes. This is just gonna help you for the formative you gotta fill out later for your attendance. All right? All right, so basically you keep doing this and you keep filling in the chart. All right, now we're gonna make it 80. There we go. Okay. All right, 13.9. And we divide that into 219. 13.9. We get 15.7. So we're just going to say that's 1/16. 1/16 F. And then we go to 5R. So to 100. Too much. I was better at 99.9, wasn't I? There we go. Taking that out to, okay, 9.07. Divide that into 2/19 because we're seeing how much of the original it is, right? It's a fraction of the original. Why is it a fraction? Because it's in that, it's dividing, right? It's divided into it. So 9.07 to 219, we get 24.1. All right, well, it's supposed to be 25th, so we're going to fudge it a little bit. It's because I don't have it exactly where it really, needs to be here. All right, now we're going to take it to 200. We're going to maximize this baby out. There we go. All right, we're going to call that 2.27. And we're going to divide that into 219. All right, and that one's really off. It's because I don't have this exact, right? Okay, so what is it? It's 10R. What's 10 squared? That's right, it's 100. So what it really should be is 1. Let me go back to here so you can see what I'm doing. All right, so it's really 1/100th F, right? Because it's this squared. So whatever this is right here, it's just going to be the square. What? Yes, that's right. It's just going to be the square. So what's that mean that the rest of these are going to be? Well, this is this is 20, right? Let's square 20. It's 400. So it's going to be 400th F, right? It's getting really small. This is 30. It's 30 squared. What is 30 squared? That's right. It's 900. So this is going to be 900th of the force. All right. So we keep doing that with the simulation. We get these charges. We divide them into 219, which is our original, and we get the force. And then you answer this right here. All right. So that just says, if I move it 200 this way, get 200 that way, is my force going to change? No. Why? So what's that telling you? So is my force going to be different over here? Right? It's proving to you that what? That what? You know, it's kind of wonky. Get over it. It should be the same all around. Okay? So the force goes out radiating from the field. All right, then we go to the second page. Second page is where we keep this the same, the distance the same, and we're changing what? We're changing how much charge is there. So more than one charge, and we're going to take this out to 200 because I want to, 200, there we go. And from the original, from the above chart, it says, what was at 200? What did we put at 200 centimeters? 200 centimeters, it was, well, what was 200 centimeters? 200 centimeters was 2.27. All right, 2.27 volts per meter. Here we go. So now we're going to put this here, 2.27 volts per meter, and that's going to be our 1/4. So we're going to represent everything from that. We're just seeing how that changes right there. All right, so 200 meters, I probably should have put what this was. Oh, there we go. All right, so now we're just going to make another chart. So there's already one here. So if we put another one in the same place, how does that change that? Well, how does it change it? We got more of a charge, right? We got 4.6. Write that down in number 2. All right, then let's put another one out there. Let's see how that changes it. All right, 6.9. Write that down. Let's put another one. This is our 4th one. And probably should put it exactly. And we got 9.14. All right, let's put our 5th one. And we got 11.4. Okay. So now I need to go back to here so you can see what I've been writing, right? All right, so we do this the same way. How much, if this is 1, the force of 1, how much more is this? Well, I bet you can guess. So if we look back at Coulomb's law, right, there's Coulomb's law. So what we're looking at is we're changing this right here. This is the amount of charge. These Q's, these are little Q's. Okay, little Q's. This is the amount of charge. So what we're changing are these Q's. All right, so we're increasing the charge. We're keeping the distance the same, increasing the charge. All right, so we increase the charge by how much? By 2. So that means it should be about twice that, is it? Well, it's supposed to be, right? 2.27 divided by 4.16. Yeah, it's half. So 4.60 divided by 2.27 is 2, right? 2F. And so now we're going to do 6.9 divided by 2.27. How much should it be? It's 3 here. I tripled it, right? So that should be 3F. See how this is going? Yep. All right, 4F and 5F. So I'm guessing you can guess what that is. All right, so this is Coulomb's law. So if we change the charge, right, we're going to increase the force that much. If we increase the distance, it's going to have the inverse effect. Coulomb's law is an inverse square law, right? It inversely, right, affects the force. Distance inversely affects the force because we have the division right here. And it's also squared. So even though we took it to be twice the distance, it's not half because it's squared. So it's 2 times 2, which is 4, so it's 1/4, right? This is 3 times the distance, but it's not 1/3 because it's squared, so it's 1/9. All right, see how that's working? All right, here 4 times the distance, but it's not 1/4, it's 1/16 because it's squared. All right, so these are your notes. You are going to use these to fill out, and we don't need that anymore, to fill out a formative. Hello, come up, thank you. All right, this is what's great. There's nothing to draw. I know you're thanking me right now. You're welcome. All right, so there's nothing to draw, like the last formative we've had. Okay, all it is, multiple choice. That's right. That's right, multiple choice. So there's no guessing. It's going to show you your answer. It's going to be correct. It's going to be beautiful. So do this next. That's going to be your attendance, at least for my kids. Okay. For other teachers, they might want to do the next assignment for attendance. I don't know. For my kids, this is what they have to get done to get their attendance. All right. Then after you look at that, then the last thing to do for the assignment is not that. It's not that. It's not that. Where the heck is it? There it is. All right. Back on your assignment, right here, you have the Discovery sign-in. Yes, that's right. All right, so you sign into Discovery. Everybody should have an account. Sign in with Google. It'll get you in. You've probably been there before. All right, and so you're going to read this right here. It's going to talk about, what does it look like? That's right, Coulomb's law, which I already talked to you about. So this shouldn't be anything new right here. It just reinforces it. All right, reinforces it, reinforces it. You could read that if you'd like, or actually if they're videos, you could watch those if you want. Sample problem. All right, and has a little dude here. He is doing Coulomb's law, but he's finding distance. Wait, we only found the force, right? Well, I don't think you're going to have to find the distance. This ask, is it attractive for yeah, this is the force. This finds the force. The next one finds the force. The next one, what is the charge of the other object? Oh, that finds the charge of the other object. What is the force? So he's doing some math that you're not going to have to do, but if you want to look at that to see what's going on, please do. All right, so you do these 4 problems and look their multiple choice, right? And you need to know this constant. This K right here, this K, that big K, that's a constant. It means that number never changes, okay? And that number is this number right here, the 8.99 times 10 to the 9th. It's basically 9 times 10 to the 9th, okay? Just use that. It's fine. Use that for K. Use find Coulomb's law. Use it right there. Multiple choice. Submit. It'll tell you you're right or wrong. All right. And then this is your very last thing. Very last thing. And you just pull these down here. You read it. You drag and drop. Drag and drop. Done. And that's going to be your last thing for today. For my kids, that's going to be their grade that I'm going to put in the grade book. I didn't mean for this to take a really long time. That's why I helped you with the notes. These are just pure notes. But I did think we needed to do some work with some math. But at least you got some multiple choices, right? So if your answer come out of your calculator doesn't look like one of that, doing something wrong, come see me in office hours. We'll figure it out. I'm here for you. Signing out. And I can't stop it. There.